Blame it on this transition.
Hi guys, sorry about that. I had a power outage and we can't figure out how to work YouTube now. I just figured out Google Plus and now we have to figure out YouTube. So I don't see get that. I don't see anyone in the room, but I see the people here are starting to fill up. I posted the link to the new. Well, if you knew where the link was, you'd be here. 2 viewers. Okay, they're starting to fill up the room. Then what I'm going to say is, David, you can probably start us right off and go right back into it. And
okay, so it sounded like we were. I was in the middle of answering Tolga's question about selecting stars. What I use to find the particular stars that I think are going to be valid. So in general, what I use is this the equation on the left side. So as I select stars, I'm looking to see that it's Moffat or Lorentzian. I'm also looking for key things like if I select a star, I'll click on a few others here. Like this guy is at a very different angle from the rest. If I see something where his shape is very different from the rest in the general area, that's probably not a valid star, so I'll exclude that one. I also look for things like if I select the star down here at the bottom, you can see it shows up as a Gaussian. That's because if I unstretch this image, you can see the whole top is overexposed. So the best fit for something that has this flat top is a Gaussian curve. That's the best thing they can find, best model for that star. So it's not really valid. It's not really a Gaussian fit star. It's just that it's clipped. So I look for these things in there. I don't, for at least for my data, the way it's sampled, the MAD number here, the mean absolute deviation, isn't always the best metric unless it's way off. You can see all these are about in the same exponent range, 10 to the minus 3, 10 to the minus 2, with a few differences. Even this one is 8 to the minus 3, which is similar to this guy here, and that guy's a pretty reasonable star. So at least for my data, these numbers haven't been that useful. So I generally just look for other things as I'm clicking stars, like the shapes matching other stars in the area, making sure that they're Moffat or Lorentzian stars. And once I have all the stars I want to select, you have to select them all in the list, and then click on the synthetic PSF generation. So this gives me a new image called PSF, and you can see this point spread function is kind of swimming in a sea of blackness here, and that's not really the best. I've seen bad results when getting this. I get weird kind of block artifacts around data sometimes when I have this. So you really want to crop this in so the data is falling off to 0 much more gracefully. So to do that, what I do is I bring up the average star data and create a star with this. And however PixInsight is doing this under the covers, the size of the box for the PSF seems to be more accurate using the average star data result than with the synthetic PSF export. However, the angle is not correct. It's always at like a 0 rotational angle, even if there is some angle here. So if I zoom in here, you can actually, as I look at the values, you can see a readout down here on the bottom in this area. So this one is 0.3654, this one is 0.39, so there's slightly difference. There's a slight angle to this image, and that won't really be the case typically with this one. So I don't use this one, I just use it to determine how big the box should be. In this case, the readout down here shows a width and height of 11 by 11. So I'm going to close that guy. I already have my point spread function, so I'm going to close dynamic point spread function and bring up the crop tool. I'm going to set the crop tool to track images. So if I select this image, you can see it sets all the correct information for that image. If I select my point spread function, it has all that data in here. And I just want to make this 11 by 11 just like the other image. All right. So now I've got a point spread function that has the right size. However, it's no longer normalized. If I look at the corners, you can see the intensity value in this range down here is 0.0006. So it's not truly normalized anymore, so I have to go through and re-normalize it. So I'm going to do the same thing with histogram transform, turn it to tracking on, select my PSF image, and I'm going to click the zero shadow, the auto zero shadows button. And all this does is find the minimum value, and it's going to set that value to the value of 0. It's going to stretch the image linearly, so that value becomes 0 there. So when I apply that, there's no real visible change there. But if I go through and measure, you can see the corners are now all 0. So this data is now normalized again, and the peak is at 1. So now we have a point spread function, and we're going to go and generate a star mask. Now, like I said, with this data, most of the star brightness levels are all fairly similar, enough that I could get away with just doing one pass of a star mask. So when I apply this on my image, and I look at this guy, you know, when I have my PixInsight set up so that when I move windows, they become transparent. And I really like this because I can move an image over the other and see how they line up. And I can see exactly how the stars, the star mask fits over the stars. Although I don't know how this shows up on the broadcast, maybe a little too noisy. So another way to do this is just apply it as a mask. So now I can kind of dig around and look and say, you know, am I covering the stars adequately? Do they look like they're well protected? The faint ones don't need to be protected quite as well as the bright ones. And in general, this looks pretty decent, enough for me to be getting on with. So I'll go ahead and remove the mask and just put this in the background somewhere. All right. So the next thing I want to do is clone my image here. So to copy an image, you can just drag its label off like I did there. It's a nice little quick way to do that. And I'm going to rename it Deconvolution Mask. And all I'm going to do is stretch it with the default histogram transfer stretch. So if I take the settings here, you can do that by just dragging the new instance icon up to the bottom bar of histogram transformation. You can see it does some stretching. And then I can apply that to my image. All right, so now my image is permanently stretched. So you can see there's no effect on the screen transfer function. It's reset. I want to take this guy and clone him again. And I'm going to call him NR mask. And all this stuff is in the presentation. It's also, if you look at each of the desktop icons and the data I provided, there's a little notes in there. So this is telling you, you know, clone the deconvolution mask and do these sorts of things, right? So each of the processes is telling you kind of what to do. So if I back up a little bit, I can just apply this process to the image and it will do the same stretching. So I've also cloned it after stretching to make an NR mask. I'll kind of move this off to the side a bit. And then I want to flatten the image a little bit, or compress the dynamic range, I guess is a better way to phrase this. So this is kind of a quick pass of doing this. You know, generally, if you're doing HDR multiscale for an end result image, I'd be a little more careful in my application of it. I'd probably use not use median transform. I'd use the Gaussian scaling function instead, and then I would use a star mask to protect stars and things like that. And you can see the difference is fairly straightforward. It just compresses the dynamic range, so bright things are not quite so bright, dark things are not quite so dark. And now that I have this, I'm going to clone this image, and I'm going to rename it TMP for temporary. And this is what I'm going to do all the contrast enhancement on. So this is a process container. So you can see it has multiple steps in it. And you can look at each step, right? So if I double-click this, you can see this is running local histogram equalization. There's a kernel radius of 256, contrast limit of 1.5, how much, what the histogram resolution is. What's really important here is the kernel radius, right? So this is the scale of the structures that it's going to try to create contrast between. And if you look at each of these, you'll see there are successively smaller numbers. And you can kind of see that in the text here. You can see PixInsight is showing you the code to call local histogram equalization. They're saying, oh, this is my kernel radius 256, click on the next one, it's 128, so forth and so on. And the last one is multi-scale median transform. And I'm doing the same sort of thing here. I'm boosting the contrast using the bias offset for each layer. And you can see also that I'm decreasing as I go up in scale here. So I can do all those things in one pass, right? So I can apply this whole process container to my image. And it'll take, 30 seconds to go through here. The longest one is the highest level local histogram equalization. That takes the longest. All right. So that's done all of those steps together. And you can kind of see the difference. There's a big difference in contrast. The dark nebula are much darker. The brighter regions really kind of stand out a bit more. So that's really what I'm kind of going for here. So the next thing is I want to really see what the differences between this image and this image are. And that's where this pixel math expression comes in. I'm going to apply this to this deconvolution mask. And so this $T identifier is saying whatever image this is applied to, or the active image, that $T represents that image. Otherwise, I call out the image by name. In our mask for this image, TMP, temp for this image. And you can see ultimately what I'm trying to do is take the difference between this image and this image and modulate it by the brightness levels in this image. So when I do that, this is the result I get. So you can see it is a little bit brighter in the middle, but mostly what I'm seeing is contrast areas here, where I have a big change between bright and dark. You get some of that around stars, some of that around some of these dark nebulae. You can see it's still bright in the middle, dark right on the ridge, but not exactly including the, it kind of blends over the edge a little bit. So you get these kind of contrast areas here that are identified. But then you also get fall off. It gets darker where there's lower signal-to-noise ratio. So I'm going to minimize some of these other images to get them out of the way. And the next thing I'm going to do is, if I look in this, I'll just do a screen transfer function. So this is I just stretched it with the screen transfer function with the keyboard short Control A on my machine. So I can see there's still a fair amount of noise in here, and I want to kill all of that. So this is where I use the TGV denoise. Again, I would define a preview. So click on the preview and select an area of high contrast, maybe something like this. Then I would, do my processes on here, changing the edge protection and strength and stuff until I get something that I like with this data. I'm going to go ahead and run this on the full image. I have a reasonably fast machine, so this doesn't take too long, and the image data is not that large. In general, I'm not touching the strength or smoothness settings. I change the iterations to 500 and then vary the edge protection to get a result I kind of like. And you can kind of see it's kind of blurred a lot of the edges, but those same contrast regions still are there. Actually, this may have been a little too much. I think I'd done a previous pass of this, so I may actually knock this back one level. So I'll do one little test here. I'll drop it down one level. Still a bit too much. Not quite enough, and then I'll, keep doing this until I'm pretty happy with the results. So that looks pretty good. And then I will go ahead and apply that to the image. So that's generally what I'm doing here, and you can see because the noise reduction mask is already stretched, I leave the midtone shadows and highlights all the same. I'm not changing anything there. I'm just using the noise reduction mask as a model, a support image for what the noise looks like in the image. All right. So I'll kind of move this out of the way. Now we're ready to do our, let's see, which one is this? Oh, this was stretching the deconvolution mask. So, yeah, I have it auto stretched there. So I did want to stretch it a little bit. So if I make it a little bit larger here, it's kind of dim. It's not going to allow much of an effect. So I'm going to brighten it up a little bit. Maybe not quite that much. I'm just changing the midtones here, trying to get a little bit more permissiveness through the mask. All right. Okay, so I've applied this as a mask, so you can do that by dragging this image just like you're going to make a copy of it to the left bar, the title bar of this image, right? And that applies it as a mask. You can also do it through the mask. You can select a mask for an image. You can see I've got the deconvolution mask selected here. You can invert it. So, this will protect these high contrast images and allow the noise to be affected. We don't want that. This one will allow, you can see it's more of the image passes through here. The redder it is, the more protected it is. I'll turn off the visibility of the mask so we can see the image as we affect it. And then I'll do the same type of thing. I'll draw a preview over a specific area. I may use screen transfer function on that preview just to kind of see what's going on at those brightness levels. And then I'll tweak these parameters. Right? So we'll go ahead and use the parameters I've set up here. And you can see it's going to be difficult to see in the video stream, unfortunately. So you'll have to look at the reference images and go through this yourself. But so this is with it applied. And if I leave it alone for a little bit so the image kind of stabilizes through the video stream. And this is with it out. And really what I'm looking for is that kind of snapping into focus effect, right? And this is pretty good. I see most of the structures kind of toggle in. I don't see a lot of noise build up. So I might try another area where I have a little bit more dark stuff. So I'll draw another preview over here. Do the same thing. And you can see I get a little bit of contrast on the edge between the dark and bright nebula here. The stars kind of peek up and pull in a little bit more. I get more contrast on here. The edge delineation around this little globule here is a bit better. But I'm not really seeing any kind of additional noise in these dark areas. And that's exactly what I want to get here. All right. So once I'm done with that, I'm good to go on the rest of my processing. So I would take this image, I might, get rid of these things since I'm done with them, or I might keep them around. I may choose to do some other masking with, my noise reduction mask or something like that. But at this point, I would go through and do my the rest of my processing. So I'll do one other thing here. I'm going to clone the image and put them side by side. And I'm going to back up and undo the change on this one. Try to zoom into the same approximate area. The sizes aren't exactly the same, and then I'll back off the stretch a little bit. Looks like I lost something there. Oh, I didn't actually apply this to the image. I just did the previews. Okay. So that takes a little bit longer to run on the full image. So while this is running, Adam, are there any other questions about the steps that I just showed here?
I haven't seen any more questions, but now that a bunch of viewers are back in the room, remember, guys, now we have chat in YouTube. So if you have questions, just type them in there. And sorry about the downtime. I had a power outage for about a second, and it screwed all that up.
Now we're going to be pitching in money to buy Adam a UPS, I think was Josh's comment.
Yep. I don't know whether. Oh, go ahead.
Can I make a quick comment? It's John here. Everybody who's online here, if the mic isn't muted and there's a tiny noise, it's bringing up your video and blocking what David is doing. So it might be a good idea, unless there's a question, to just mute your mic, and then that'll keep the video flowing.
I think that's only within the room, John.
Yeah, John, you can click David's avatar on the bottom, and you'll be locked on him.
Okay, thank you.
I'm in control of the camera for those guys, and that's why they lost him.
Okay, well, when I applied that the last time, I didn't have the mask in place, so it kind of overdid things a bit. So that was really the presentation. If you have any other specific questions, regarded to fine-tuning some of the other, some of the deconvolution parameters, I can go over some of those, or anything else that y'all are interested in here.
I think the most interesting thing is the contrast mask you make. It makes a lot of sense. I never would have thought of doing that. But
yeah, I don't know how well this shows up side by side.
For me, it's showing up pretty well.
Okay.
It shows up really well, and David, I have to say this is a fantastic presentation. I've played a lot with the deconvolution, and frankly, it's kind of, for me, it's hit or miss, and I think your suggestions are really good here. So I just wanted to throw that out, in that your results are impressive. I've got to run, but I'm really impressed. I'm going to have to study this and give it a try myself. I think your results are really outstanding.
Good. I'm glad you liked it, John. There's one other point I didn't cover here, and that was kind of tweaking some of the wavelet regularization settings. So if there's no other questions, I'll do that real quick.
David, I do have a question for you, but maybe you're just about to go over it. One thing that I run into pretty frequently is that you can get the settings to the point where you get really a nice increase in contrast and sharpness with the deconvolution on the good details, maybe on the core of a galaxy or something. But as you get there, you also get a little bit of that kind of webbing look to it. And it seems like it's hard to mask that out, because you'll even get that webbing in the brighter areas. But it feels like when you pull back on the settings that produce the webbing, a lot of times it also pulls back on the amount of sharpness and clarity that actually comes out. So the contrast mask helps that somewhat, but maybe not as much on the very bright parts. Do you have you?
Yeah. So what you're running into is a couple different things. So one, I think you may be pushing the deconvolution a little too much, right? So on those really sharp edges, you're getting too much. One of the things you can do is, this contrast mask definitely helps with that. However, those really bright regions are just going to be, still overblown. Like if I allowed it to, I think there's actually a few stars detected in here, so it's not overdoing this kind of blob in the middle, because in my star mask, there's a little bit of control there.
Mm-hmm.
I found two things affect that. One is the noise in the image. So like if you've done some sort of HDR in the image, well, not if you're going to be doing some sort of HDR in the image, and you're looking at it stretched in a way that you would see that particular brightness level of detail, the buildup of noise in there may still be too much for the number of iterations and stuff that you're trying to do. And so that noise effect comes in and starts giving you that kind of chunky, blocky look. Like, so if I take this preview and I, up this to 100, I'll have to apply the mask first before I do that, otherwise it'll look really, really bad. All right, so now if I go to my preview region, that should go very quickly. Even then, it's not getting too chunky with this particular set of data. Make an even smaller preview. But mostly, Josh, I encounter that when I have still a fair amount of noise in the high signal areas.
Mm-hmm.
And my mask here is just protecting it well enough that I'm not really seeing it. I just start to see a little bit of it right here. This contrast mask is pretty good because if you look at the mask, you can see it's allowing some here, but it's not exactly just on the center line of the ridge, right?
Right.
So it's allowing the contrast on kind of either side. And the same with this region over here. It's not exactly the center of this contrast between the two. It's actually, off to the edge a little bit. So
yeah, and that's where that stuff gets a little bit worrisome to me, because I'm always a little afraid that I'm introducing artificial structure, because sometimes structure at that small scale can look similar to webbing at that small scale, and it's a little hard to tell, when it's actual structure you're revealing, or it's some kind of aberration of the actual process.
Yeah, so if I'll take the mask off here and restretch this, and I'll use a much lower number again. If I can get the effect that you're talking about. Yeah, you're just starting to see kind of nodding and stuff in here that probably isn't real. Like these little pockets along here in this region, there's kind of nodules that I see showing up.
Mm-hmm.
And that stuff is generally because you're overrunning what deconvolution does. It's actually deconverging in its algorithm rather than converging, and you get these kind of nodules that show up. I don't really have a hard and fast fix for that, Josh. It's mostly about signal-to-noise ratio and tuning the mask so that it works well. If you're seeing areas where you're starting to get that, but you're really not getting enough improvement in other areas, I would kind of selectively decrease the brightness in the mask in that region.
Well, so that's what I was going to get. I guess my one solution right now is to make several different maybe deconvolutions and then layer them over the original image with masks that reveal certain areas. So, so instead of just a global application of the deconvolution, having one set maybe deconvolving the majority of the image, and a different set deconvolving the dark dust lanes, and maybe another one on the bright stuff. But
yeah,
tedious.
It's unfortunately tedious. I've seen people use things like, for example, M81 and M82. It's a good example, right, where you have two galaxies are kind of separate from each other, and they'll kind of have a mask that identifies the galaxy and removes the stars from the mask so that it's only working on the disk of the galaxies. And that way you have a little better control over it. You're not really affecting anything else. So you're kind of combining masks in that aspect for doing the deconvolution. But you can certainly do different passes of deconvolution in different areas and then blend those things together too. I think either would work well. I've gotten really good results from using this contrast mask versus using just a straight luminance mask. If I use the same mask again, I'll look at that same preview again. And part of this may just be that I've tuned. I'll take a snapshot of that. I'll pull the preview off so we can keep an image. Then I'll use the deconvolution mask here and do it again. And you can see already that some of the getting a whole lot of stuff here that looks like it's enhanced a bit more, but is probably not really there. Like you said, it may be artificial. Where the contrast mask is doing a little bit better job of controlling that and just allowing the stuff that really does have some amount of contrast in it to be sharpened a bit effectively.
Looks like we lost Josh now.
But we're still online, right?
We're still online, yep.
Okay.
So, David, I'm sorry, for just as you're using deconvolution similar to the way I use it, but I don't do any of the kind of focusing on the contrasty regions. Would you mind pulling up the equation you used again?
Yeah. Move some of these things out of the way real quick. All right, so the equation was here. So it's pretty straightforward. You're doing a difference between what was originally in the deconvolution image, which was this, and this temp image, which had all the contrast enhancement. So this is the image before, this is after. So all you're really doing is subtracting this one from this one, and you're doing an absolute value. So the median value should be the same, and so really what you should see is areas that got darker here should be lighter in the end, and areas that got brighter here should be darker in the end, right? And if this is done by contrast size, because we've done this structure enhancement at different scales, so you'll get different scale buildup of those different structure sizes. So you'll get this difference. And what that really gives you is, like you can kind of see here, I stretch it a bit more, the top of the ridge itself doesn't have a lot of contrast in it, at least not at the scales that I've stretched. But the edges around it, as it falls off more rapidly, it does, right? So you get these nice effects there, where it's going to protect things from, like Josh was saying, getting some of that webbing effect, right? It protects it a little bit from doing that. So some of the other settings I have in here protect as well. I didn't talk about doing the noise protection stuff that much, but in general, I'm just taking an image. I'll take a preview and that covers a particular area without a mask on. And then I'll tweak the settings. Typically start with this default of 3 and see what kind of results I get. And I'm seeing a fair amount of noise back there, so I'll up the number of layers and keep doing that till I'm seeing a reasonable result. For my particular data, 4 was pretty good. But this is unmasked entirely, so it's never going to look great, but I'm not seeing a lot of noise build up in the background, is what I'm looking for there. Same with the de-ringing settings. You can play around with this some. If you set it too high, you really won't get any results on your faint stuff, right? So this is a setting, essentially setting the bottom limit where it will start rolling off and clipping the ringing effects, right? And most of my data is very low. You can see the values down here, over here are 0.01, things like that. So I want it kind of a little below that, and most of my data, 0.005 works pretty well. It's low enough. It's it's not going to be an issue. And then I just tweak the number of iterations until I'm getting a reasonable sharpening of my data. 50 for mine was pretty good, and then I add in the mask. Right? Did that answer your question about the pixel map, Adam?
Ooh, I muted myself. Yeah, it did. And you don't, so like the 0.1 times noise reduction mask, you don't have to modify that 0.1, right? Or do you?
You may want to, right? So you might experiment. So for example, here's the deconvolution mask. I'll unstretch it some. So here's the original image. So for example, I'll make a clone of this real quick so I don't modify the other one. So what I started off just trying to do was look at the difference only, right? So this is the differences, after the contrast enhancement. It's like, okay, well that's great, but all this background stuff is going to be affected, and I don't really want that, right? So that's where I started modulating by the original image, right? Because it has fall off for the dark areas. Okay, so I'll try that. That looks pretty good, but I'm still seeing a little bit too much, so I want to kind of average it with what this original image looked like, or the unstretched, undynamically compressed image, right? So all this, 0.1 times NR mask doing is averaging in a little bit of the original stretched image. That's all it's doing. So you get a little bit more brightness and stuff in there, and you can just play with this value. Maybe you want a whole lot of it in there to get something a little bit closer. But in general, 0.1 has actually worked very well for me, and then I just stretched the image a little bit after that.
Okay. So yeah, so I'm trying to think about it. So the noise reduction mask is basically just the noise reduced luminance, right?
It's not even noise reduced. It's just the original luminance stretched.
Oh, okay, okay.
So it's just a copy of this image. It just happens to be stretched. So the order was, I took the image, copied it, renamed this to deconvolution mask, stretched it, and at that point I cloned NR mask from that. And if you look through the history, you can actually see, if I click on NR mask, right, you can kind of see it was cloned from deconvolution mask, and then I renamed it. That's all that happened to it.
Okay.
And you can actually see some of the history of what happened to the deconvolution mask as well. But
yeah, that's really cool. I mean, you're basically, first of all, I'll say your results look like the results that I get after all of my steps of sharpening and stuff. It was really dramatic. Usually with deconvolution, I'm just hoping to get a little bit of something that gives me a toehold later in processing, but your results were pretty dramatic.
now it's obviously going to be dependent upon your data, right? Noisier data is more effective. You're not able to get as much out of deconvolution if your data is fairly noisy, right? You just can't push it as far.
Very cool. Any other questions in the room or questions from chat now that we have a chat? I'm not seeing anything else. Well, David, thank you very much for that presentation.
Sure.
I can't wait to try that out, but I need a couple clear nights before I can. Just checked, maybe tomorrow.
That's good. I don't think it's until next weekend before I have some clear skies again. So.
Yep. Yeah. Well, weather's been awful, so hopefully everyone's luck turns around. Let me
Adam, I have some information on Carlos David's image of the week from last week, the Ro Fiji region.
Go ahead.
He's very grateful for us selecting his image, and it is a beautiful image, by the way, Carlos, so thank you for sharing that with us. This was 60 times 60-second exposure at ISO 1600, the Canon 7D and Nikon 180 lens at f2.8. The mount was a Sky Adventure Mafado tripod. It's taken from the Cape Cod National Seashore near Truro, processed in PixInsight.
Awesome image. Thanks for submitting it, Carlos. Yeah, so basically we're trying to figure out how this YouTube stuff is interacting. Hopefully the chat helps out. I saw it was in use today, and until we come up with a better plan, that's going to be the best way to get us questions. Next week's presentation is Krister Strand's ASA, what is it? Unguided imaging with an ASA mount. So that should be a good one. The following week we have something interesting we're working on. Basically an all-in-one Linux teeny PC to mount on your computer, open source software. It's going to be pretty cool. That's Jassim, I forget his last name, but that's posted, so check it out. Oh, and John wants to, well, Alex isn't in here, but we'll pass on your thanks for the recommendation of the Deep Sky Imaging Catalog. Awesome. Well, David, thanks again. And guys out there, we will see you next week.